Smoky. Is this how you spell Smoky?
Yeah.
Okay. Let's console log here. Dog. Let's console log cat. I don't know how you can add a key to an object like in this way. I guess we can learn. Let's console log those two. Oh, so this gave us what we are used to. This, oh, this is confusing. This created a string object, not a string literal. So anyway, let's create it like this. That creates an object. If we want to add a key, then we're going to need to add it separately. Okay. Other questions or thoughts on this one? Cool. What was the second question? How do you add a key?
Yeah.
To an object, yeah.
Okay. Let's leave these guys here. Jonathan, how do I add a key to cat? I want to add what's color or fur color.
Name.
Oh, let's add a name, yeah. So how do I add a key name to cat?
Cat.name equals Smokey.
Let's console log this. Now we have a dog and a cat, both with names. Cool. Other ways to add a key to an object.
Can you also do it in brackets and make the name?
Tell me what to type.
Like cat, the array brackets.
Square brackets.
Square brackets, yeah. Quotes, Smokey. Actually, no, quotes, name equals something.
Well, actually, that key already exists. Let's do for color.
Okay.
It's black, right?
Yeah.
Cool. We added two keys to our cat. Here's a question. Can we add a key without a value?
If you put no, does that count as the correct answer?
Yeah, I mean, I think that what that leads us to is like, what do we understand by a key without a value, right? Like, is it that the key doesn't exist, or is it that the key exists itself, but the value is undefined or the value is null, right? So there's no I guess right or wrong. If you want to add only a key, the short answer, like I guess like if we were strictly correct, you can't add a key without a value. You always need to say the key and then equal the assignment operator for the value that you want to store under that key, right? But we could do, maybe, I guess, legs, number of legs. We could say undefined or null, as Cameron suggested. And that adds the key, but it's just that there's nothing stored in the value. Cool. How do you add a value to an object? Or any clarifying questions that you can ask?
Are these two questions similar?
Yes.
Obviously the same thing we did before.
Exactly, that's the right answer.
Same thing.
The same thing. You can't add anything to an object if you don't have a key. So let's do Same as above. So you can't have values without keys. That's what we said. An object is a key value store, right? It stores key value pairs. Cool. The other question was, how do we check if a key exists? This one is interesting.
Can we use the has own property function?
Yep, that's correct. Let me come here. Check for key in object. So tell me what to type. So let's say, yeah.
Shit, I had it earlier. It would be cat dot has own property.
Mm-hmm. I'll put a console here. Oh, actually, maybe do this. Let's say has for color. So you said cat
That has own property.
own property.
Fur color in quotations.
In quotations. Important those quotations there. And this console log here has for color. Let's take a look at this. Oops. Has for color is true. Cool. So this is one way. And so how do you, or Joanne, how do you do?
We did a condition.
Okay.
We did a function. Does key exist? And then we did if object name. Well, mine's in this case would be object dog. I mean, if dog dot name.
So you said you have a function like this.
Yeah.
And you
So
say
then if dog, and let's say you're looking for a name, then curly bracket return true, else return false.
yeah, this is fair.
This is so many lines that I think has
It
own
is.
property is better.
Right. How could we take this function and have it work as has own property, basically, that it takes in a string. So what if we want to look at the key here? Oops. So when I call it, I can call it like this. Console.log. I guess has name, and we can do. Oh. Well, let's say we get the object here. So this argument, does key exist, takes in the object and it takes in the key. So we can say something like, does key exist? And we pass in the dog, and we want to check if the name key exists. How could we? What do I need to change here in this function for this to give me true? That when I pass in the dog and I pass in name, you can tell me if the dog has a key called name.
Would you just have to change in the if condition name to?
Okay.
I'm not sure, honestly.
Yeah. Or other ideas?
I don't know. I was gonna say dog.name is equal to and have a string.
Oh, something like this.
String name, something. I know.
If we do this, we are checking if the content of the key or the value of the key is Pluto. But we want to check if the key itself is there. You just want to see if it has that key.
Couldn't we exchange dog for object
Yeah.
and name for key?
We need to do this. And this is close. This is a very fair guess. You say, well, if that key exists within that object, return true. However, let's try to run this. Dog has name is currently returning false.
Oh, I'm sorry. Object, and then can we use square brackets in the key?
We will need to use square brackets here. Any ideas as to why?
Man.
Somebody
Because
else?
we don't know.
Yeah, that's a good explanation because we don't know the key yet. In fact, this key can be anything, right? It can be, for instance, let's try this. We know that the dog has a name. Let's also say it has a weight. I don't know how much a dog can weigh, but let's say 25 pounds. And we can do this. So dog's key exists, and we can say weight. So we want this to give us true. Right now, let's do a weight. Did he spell this correctly? Yeah.
There's a T.
The T, the end. Yeah.
Oh, yeah. Thank you. I knew that was a spelling mistake. Cool. So right now, our dog here has name and weight. Wait. Okay. So I'm missing the weight here too. Put this on the side. And right now, our function is returning false. If we do it with a has on property, that works. We're trying to sort of, I guess, implement our own has on property in a way that we receive the object and the key. We were saying we need to use square bracket notation here because here we're literally looking for a key called key in the object, in the dog, and we don't have a key called key one. In fact, if we run this now, one of these should give us true. Actually, both give us true. Both give us true, but it's giving us true because our if statement is literally looking for a key called key, right? So because we don't know what this key is going to be, it's going to be name or weight. We need to use square bracket notation here. Let me remove the key from here. Now we got true and true again. Let's put a has fur color, for instance. The dog doesn't have a fur color key. We should get that one as false. We should get that one as false because the dog does not have a fur color, right? This has a name when we use this notation. Anyone remembers that name? It's important because you're going to use it a lot, especially for the pronouns that are common. Well, I guess mainly you know that there's two properties for two ways of adding a key. One is with the literal name and square brackets, a string or something that contains a string, like key. So there's two ways to add keys to an object with the dot notation, the square bracket notation. The square bracket notation is known as computed property JavaScript. Computed property names, object initializer. Let's see which one could be good. Yeah, I think this one. Yeah, so you wanna, if you don't feel fully comfortable with it, do some research on that. And we're gonna see how that's important for the next question, or actually the one after that. Okay, does this function make sense?
Yeah.
Okay. Well, questions up until this point? How to add a key, create an object, how to check if the key is there. So we said how to add a value, same as above. You can have values without keys. The other was how to check if a value, this one is interesting. This, I'm gonna comment this console log out. How to check if a value exists within an object. So we know how to check if keys exist. How do we check if a value exists within the object? What were some of the answers that you contributed?
I was using index of.
Index of.
Yeah.
Tell me what to type.
See.
Let's see. I want to check that black, the value black exists within the cat.
Mm-hmm.
So how do I do that?
You can put so like object dot, what was it? Oh, sorry, cat dot. Are you making a new object?
So I'm just making a variable where we're going to store the result.
Yeah, object. So it would be like cat, I think, right?
So you say object, capital O? Or you mean
It should just
cat?
be, yeah.
Cat, okay.
That's how it works. And we're looking inside of the fur color, so it'll be fur color. Can we do that?
So
Or
let's say we don't know what key we want to do. Actually, let's write this function has value. This function is going to take in the object and it's going to take in a value to find, right? And we're going to call this function with like this, console.log has value. We're going to say the cat, and I want to see if any of the keys in the cat has black. I don't know how many keys there are in the cat. Well, we know here that there are there's three keys. There's name, fur color, and number of legs.
All right.
Right? And we want to check if any of those keys has black as its value. Sergio, what do you have? Or Savita?
I don't know.
Okay, that's fair. Any other team managed to get this one?
We did it away, but it's not dynamic the way that you want it.
Okay. How did you do it?
We did it literally with a condition saying like dog.name, 3 equal signs, and then the value that you're looking for. Return.
So you did something like cat.name.
Yeah, smoking.
Well, I guess let's do fur color. Black. Then return true, right? And this will let you know if I guess the value that you have stored at fur color key is black. So right, that's correct. This wouldn't be dynamic because we don't know how many keys the object has, and we don't know which one has the one that we're looking for. But that's fair. That's so.
So could you?
Yeah.
Could you do the object square brackets value define, and then put the dot notation after it for index of? Instead of hash,
tell me that again.
instead of hash value, we put
Uh-huh.
object square brackets value defined.
This is interesting. Like something
And then
like
after
this.
yeah, after that you put dot.
Here.
Actually, no, that's not right. But we put fur. You put fur in there. So object dot fur has color. That has fur color, and then you would put dot index of.
I think that is not making sense. Well, let's think about this part. Like, if we do this, we say something like, we're gonna need an if statement, that's for sure. If we do this, return true. Those return false. Oh, also, I think this is, I guess, as a side note. Whenever you have an if statement that only has one statement, you can get rid of the body has only one statement. You can skip the curly brackets. So I could write this like that. And in fact, there's a way in which we could do this shorter, where we just return this. But if we do this, if object value to find, then return true, else return false. What are we treating value to find as here?
As a key.
As a key, that's correct. So this will look at black as a key in the cat. But black is not a key in the cat. Black will be a value in the cat.
Right. So you would have to actually put the key that you're looking for inside the object. Should you actually pull in the key also?
What do you mean by that? By
In the arguments.
Oh, like here?
Yeah.
Yeah. So if I do, yeah, but then this defeats the purpose a little bit. Here's we're gonna see like this.
Wait, what's the purpose? We're finding if the key has an object, right?
No, we're finding find if a value exists within an object, but we don't know under which key that value is.
Oh, okay. So just checking the.
So
Would a for in loop work or no?
Exactly, that's what we need. So for
Oh,
in
so
loop.
that's what we did. We did a for in loop.
Cool. So tell me what to type here.
Oh, I don't know if we did it right, but we did a for in loop.
Well, I guess just tell me what you have.
So we wrote for key in object. And then we wrote if object at key equals, I guess, value to find. Return true. I don't know. Else return false. I'm not sure if that's correct.
The return false, we wouldn't do it inside of the loop, because if we return false and the first key, we're looking at the first key and that key doesn't have the value we're looking for, then we're gonna quit and we're not gonna check the other keys. What we want is
outside of the first, yes, outside.
Right, that's correct. So here will be the false. Cool. Let's see if this works with black. Also, actually, let's make it. Well, yeah, return true. I think I need to comment out this. We have true for that. So that is, we found black in one of the keys of the object. Let's try to find, what was the number of legs is undefined, but let's try to do a Smokey, which is the name of the cat. Let's try to find that one. It did find that one. Let's try to find the value hello in any of its keys. Now we get false. Any questions or thoughts about this?
Yeah, I want to try a different one.
But before we try a different one, yes, there is another one. I want to make sure that everyone gets this one.
I have a question.
Yep.
So we're using a for in loop, which is syntactic sugar, right? Like,
Mm-hmm.
is there any value in knowing the long way of how to do it?
Wait, what do you mean by the long way? Because I think both ways. I think this is the long way. Well, I
Oh,
think both
okay.
both ways are about the same length.
Like using like a regular for loop instead of like a for in loop.
Oh, okay. That's a good question. Can we use a regular for loop to iterate over an object? Anyone who wants to take a shot at that?
You said a for of in the object?
So I guess no for of. There is a difference between for in and for of, but for of wouldn't. Oh, wait. Say that again, Jonathan.
I was asking if the other way was a for of, and I don't think a for of would have worked.
Let's try this. I think for of don't work on objects, but maybe I'm misremembering. Let's see if we get that console happening.
No,
Yep. So we get object is not iterable. So for of will all work in arrays, not in keys. So this is we can't really loop with a regular for loop. We can't do for let I equal 0, while I is less than object length I plus plus. We couldn't really do this because, well, objects don't have a length, and the keys inside of an object are not indices, so we can't just go 0, 1, 2, 3 and key into those. The keys can be anything, can be any string. So we couldn't really use a regular object, a regular for loop for that. So this is a fine way. I wonder if Joy or Hupel found another way to check if a value exists within an object. Oh, actually, Cameron, you said you had something else.
Yeah, I'm just trying to I was just trying to parse it out. I think I got it.
Okay.
You want to make a different function so you don't have to delete this?
Yeah.
Um,
So I'm going to do this first.
that's value 2.
Okay. What is this going to use?
It's going to use if statement.
Okay. So I guess
Return true or not.
let me then, should I create another function that has value 2?
Yeah.
Takes in the
Good.
object. And let's say just the value.
And the value, yes. Object and value.
Okay.
All right. So if object.values parentheses.
Parentheses.
Put the object in there. Actually, can you put object as in the capital O, full letters? Yeah.
For that?
Yeah. ECT also.
Okay. Object. If I remember
Yeah.
how to spell it.
And then you put
Okay.
in the objects in there.
The object here?
Yep.
The
And
regular
then
object.
yeah, and then it's dot index of the value in parentheses.
Okay.
And then if that is greater than -1,
This is greater than -1.
yeah, you return
Okay.
true. No, not equal to.
Not equal.
Yeah. Just yes, just greater.
True. I
Well,
guess
greater
otherwise
than
return false.
yeah.
Oh, okay. This is interesting. This is the other way. Yeah. I guess let's talk about it.
Yeah.
Am I missing a parenthesis here? Yeah. Let's try this out. Let's try it. Let's make sure that it works. Let's do has value 2. Let's run that. Oops.
Too many parentheses.
Return
Yeah.
-1. Unexpected.
I think you only need 1.
Index off.
Yeah, you only need
That
1 parenthesis
finishes.
after 1.
Oh, 1. Yes, that's correct. Thank you. On this, cool. So that gives us true for both.
All
Let's try to see if for any reason the cat will have a value Alejo. Yeah, it doesn't have a value Alejo in any of its keys. Okay, so it works exactly the same. Let's talk about how this is working. First, what is this, Cameron? What does this do?
So it's an actual, what is it? What would I call it? It's like, it's like a method that's already built in, I believe, right, for objects.
It is
And you can use the values to find out how many keys are inside the object. So like you can actually, without the index of, you'll just print out every object in there, inside the object.
That's correct. Let's take a look at that. So object.keys, sorry, not
Values. Yeah.
values. Object.values is a method on the object class. We use the object constructor here. See, that's the same object. So object.values is a method in the object class, and you can pass in here any object that you want to get the values from. If we do this and I run that, well, if I
Just
comment out this call and I also console log this, we get all the values, not all the keys, all the values that the cat has. And what did we get them in?
An array.
An array. That's correct. We get all the values of that object. So another way in which I demonstrate this, let's say this is a human name. Let's try that. So object.values, you pass in an object and it gets you an array of all its keys. Sorry, not all its keys, all its values. And there is also object.keys. If I do object.keys instead of values, I'm going to get an array that has all the keys in the object. All right. So we can think of it, well, another way to do to see if the key exists will be the same way. You just get an array of all the keys and check if any particular key matches the key we're looking for. So then that's the first step. Comment this out here. So I'm going to say here, let values equal, separate this array to make it a little bit more readable. Values, actually, let me call these object values. Here we're going to say object values, the index of return true. Just make sure that it still runs. I'll comment that second one. We get true. So here we get all the values of the object. We store it in the array object values, and then we're going to check the index of the value that we're looking for, which is this guy that we're passing, which is black. And if the index of that value is something greater than -1, which means the value was found at index 0 or index 1 or index 2 or any other index, then that means we found a key, or we found the value within the object. Instead of this, I will say I will use actually includes to get rid of the -1. But that still gives us the same thing. Includes is another, we saw this in the review of array methods. It's another array method that will check if an array includes a certain value. Questions or thoughts about this?
I might have missed it, but why don't we want the object method directly inside of a conditional?
No, we could have it there. I just took it out for readability purposes.
Oh, okay, okay, cool.
Yeah, but you could have it there. In fact, all this in one line will look like this. Let's do it as value one line. Well, we can put this here, put this back here. Let's remove the returns. Remove the if statement. Say return here. We do one line. We should still get true for that one. Right. If you want to make it even shorter, is you use ES6 implicit return. Get rid of the curly brackets. Get rid of the return statement. So we don't need these parentheses. And we will still get the same thing. This is an implicit return. This function will return whatever the return value of this expression is. It's the same thing that we have here.
Under the hood, those are two loops, right?
That's correct. That's a very good observation. Object.values is a loop. Object.value is technically this loop, looping or every single key in the object and then extracting these values. So we could write our own .value. That's correct. And includes is another loop. Is a loop over the array of values that we found. That's correct. We're gonna get back to this as we talk about time complexity in a little bit. Other questions or thoughts?
That was cool.
Cool. Let me come in this. Yeah.
I had a question about why you took out index off.
Yeah, index off, that's a good question. I just think that this one, they do the same thing, includes an index off. This one is a little bit more readable than wondering about why we have that -1. The way in which index off works is, index off is going to look up the index of the value in the object values array. And it's going to return to you the index of that value in the object values array. And the index, if it was found, the index will be one of 0, 1, 2, 3, or however many elements we have in the array. And if it didn't find, if it found the index, if it found this value anywhere in the object values. If it didn't find the value in any of the object values, it's going to return -1. So that's what we did like here, greater than -1. Because if index of the value in object values give us anything that is 0 or any other positive index, that means we found the element. And that's what this is saying basically. If we have a positive index, that means we found the element. Let's return true. It's just two different ways to searching. Index of is like returning to you the index at which something is found. Includes just returns to you true or false if something was found. Doesn't tell you where it was found. I guess that's the difference. Index of tells you the index at which something was found, because that's what it returns. It returns that index. Includes returns true or false is if it was found, but it doesn't matter where, etc. Does that answer your question? Cool.
Yeah, it does.
Other questions?
Is there a reason why they use -1 as like the undefined? Because I think I've seen that somewhere else. I think Java, where -1 means undefined. Or
yeah, it was just, I don't really know if there is much history about it. I think it was just a convention. Like, oh, when something is not found and we're dealing with arrays, let's all agree in one value that we know doesn't make sense in the context of arrays. And something that doesn't make sense in the context of arrays are in the negative indices. They could also have picked, I don't know, -666. if they wanted to. But I think somebody just picked that, maybe a group of people, and then it spread to all the rest.
I know
again,
when.
Yeah.
I know in some programming languages, -1 is a null statement or undefined.
I think there's probably a Google search will hear maybe some history about it. But yeah, I think I don't know exactly why it would have been that. Other questions or thoughts? Okay, so how do we check if a value exists? This was interesting. How do you delete a key from an object? Let's call this function let delete key. We're receiving the object, we're receiving the key, and I want to delete the name key of the dog. So I'm going to say console.log delete key of dog, remove the name key. I think Kathy or Shahar, we were talking about this earlier.
Kathy, you want to explain it?
You can explain it.
Okay. So me and Kathy, we were wondering how we could delete a key without using loops or whatnot. Then we Google searched it, and there's a feature called delete. If you write delete object name sub the key you're looking for, you could delete an item in an object.
Okay, so I do delete and then object and then what else?
Array brackets.
Square brackets.
Yes, key. And now you can console.log your object to see if it's deleted or not.
Right, I guess, oh yeah. There's console log here, the dog. Console log the dog, and then also gets console log result of this, which probably going to be undefined. Let's run this. We get, I think we have, this other console log has for, let me comment that out. Let's run this. So we get undefined for the first console log, which is this. That's because our function, our delete key function does not return anything. And I guess let's console log the dog before and after the delete.
Nice.
Cool. So we saw how to delete a key. Oops, no. Before and after. Any questions about the delete operator? Okay. Can we, so we can delete a key, but if we want to be more specific, when you delete a key, you're also deleting the value, right? You can't, objects are key value pair stores, right? We can't delete a key without deleting the value, for instance. What if we wanted to delete a value but not the key? What would we do?
Reassign it.
Yep, reassign it to maybe null or undefined or one value that we settle on to signify that that doesn't exist. Cool, so this is how we can delete a key. Let's take a look at the last question, which is how can we add this key to an object?
Hey, Alejo.
Yep.
You mind sending me to Ben's breakout room? My Dessa told me to.
Oh yeah, it's fine.
8:30, but
yeah, me too.
I had to quit my Zoom, so I lost the breakout.
No worries.
Thank you.
Yep.
See ya.
Hubble, you.
Yeah, I think you have to reassign me to.
Oh yeah. Okay. Do you get it?
Yeah. All right. See you later.
See ya. So how can we add? I think I might have put the wrong thing here, but let's try this. How do we add this key that has a special character, which is the $, with the value of 5 to our dog? Let's see, Joanne, what do you think?
Sorry, say that again.
We want to add this key $price with the value of 5 to the dog. How can we add this key and that will have the value of 5 to the dog object?
Can you do dog that's price is equal to 5?
Dog that's price like this.
Oh,
5.
price. Yeah.
Let's try this out because I feel like this might actually work in this case. Let's see, let's console log dog here. Yep, I picked the wrong symbol. So this works. But what if instead of $, I had said ampersand?
Okay.
Show me a thumbs up if you think this is gonna work. Thumbs down if it's gonna break. Okay, we got 3 thumbs down. Breaking, let's try it. Hey, it breaks with an unexpected token, an ampersand. It breaks with an unexpected token, ampersand. Hey Ben, how are you, man?
Amazing. We had such a fun session, right, everybody?
Yes, sir.
Yeah.
I'm glad. But where is that background? Is that a random background or has any?
No, this is my favorite place.
Oh, really? Where is that?
It's on Cypress Island in the San Juan Islands.
Never
It's
heard.
it's like 90 minutes north of Seattle.
I'll read a little bit about it later.
I think it's with a C.
Yeah.
Cypress.
CYP.
No, Cypress Island. Like
CYP.
CYP, yes. CYP. No.
R.
Yeah, but it's ES, not US. See that Digimon? Oh my God. Alejo. CYP.
It's right there.
RE. Yeah, there you go. RE. Yep. SS. Yep.
Cypress. Well, this is another.
That's the one.
Is that something also in Europe, Cyprus?
No, this is off the coast of Seattle. Oh, the other one is in. I've also been to the other Cyprus. I have family in the other Cyprus. That's like a. It's an island it's like Palestine, where there's like a demilitarized zone in between the Greek and the Turkish half. And the Turkish half is like Palestine. It's not recognized by anyone in the international community except by the Turks. And the southern half is Greek, and the international community is like the whole island's Greek. So my family, my cousin, lives on the Turkish side. She's a Sufi, and she is like, she lives in the demilitarized. Anyway.
Cool. We're gonna send you to the other breakout room then.
Bye.
See ya. Cool. So we were talking about how to add a key with a special character, and we tried to do dog ampersand price 5 to have that key being added to our object with the value 5, but we get unexpected token ampersand, right? And the question is, well, what if I want this key for some reason? I want a very random key in my object. How can we do that? Ben, wait, did you did you get the invitation for the room?
No, we could use square brackets and quotes.
Square brackets and quotes. Bingo. Let's see.
Go Ben.
Anything popping up? I'm trying to move you around and break out.
Maybe it is, but I have like so many windows open.
As everyone knows,
I don't see one. Does anyone else see one?
I think you may need to then go out and come back in.
What the? Wait.
Okay. Now I have no idea where he went. Oh, I think he went out. Yeah, he went out.
He's just zooming around.
Zoom. Okay, we have him back. Let's see. Send him. How about now? There we go. Cool. So as Ben said, we need to use this second notation, square brackets and quotes around it. Let's try to console like that. Oops, I let the dot. When we use one or the others, we don't do the other one. Cool, and that's how we can put a key that uses special characters using the second notation. So that might be something that it could be a trivia question on an interview, stuff like that. Can you have what do you think what we're gonna get if we do this? Key object. Let me say name. Let's say, and we say dog at key object equal to somebody. I guess the question here is what do you think will happen if we try to use an object which has a key called name and a value of Alejo? If we try to use that object as a key for our dog object.
But I think it will convert it to a string, so it will be dog at object something. I forgot the name.
Let's take a look. Console log it. Now we have our special key, and now we have this other key, which is weird. It's a key, literally square bracket object, and then that's our value store. But this is not a special key or anything. This is literally JavaScript converts this object to a string. We're doing something like, you can see it actually here. Object as string by doing key object that to string. So this is, we're trying to convert an object to a string. And when we get that, we get this. We get this string. We get the object string. So because converting an object to a string doesn't make a lot of sense in terms of like, what do you expect the string to be, right? Do you expect it to be JSON? Then there's JSON.stringify for that. If you try to convert an object to a string, you're gonna get object. Oh, in fact, this is funny because I saw. Let's see if I can still show you. What is the name of? Let's see. I think I saw a bug where somebody was looking at. Let's see. What is? Oops. The history here. And I want to see if it's still there. It was in Reddit. Nostalgia, yes. No, they fixed it. Here, this part here was showing object. It was not showing a number. Yeah, so they fixed it. Anyway, that's when people try to print an object without converting it to JSON or something that makes sense as a string. Cool. So any questions? Cool. Thank you for being back. Let me share my screen here. So I have you don't see yourselves, but I have you here in this area. That's why I don't make it full screen, where I can see you. And here we have just the screen. So cool. Wait, let me put this down here. Okay. So we did this sort of a refresher on how to do basic operations on objects, how to add keys, how to remove them, etc. How to look for a value where we don't know what key has it, etc. So let's talk a little bit about the time complexity of those operations. So I hope you remember some of this from our previous lessons with Ben. So how long does it take in terms of big O notation to insert a key value pair into an array? Sorry, not into an array, into an object.
Isn't it constant time?
Constant time. Constant time. Of one constant time. Why is it of one? Like constant time. Any ideas? How is this happening so fast?
Is it doing one computation?
And what is that computation?
Adding a key and a value to an object.
I think with that you're telling me the same thing of adding a key to an object is constant time. What is the computation that we're doing? So yeah, I mean it's not wrong. It is kind of a bit hard to explain, I guess. Why is it of one constant time? But maybe other ideas, somebody else.
Because it's adding information to a place in memory that it knows where it's adding it to.
Okay, yes, it knows the place in memory. How does it know the place in memory?
Pointer to this one?
Yes, the pointer. Yeah, other ideas or surrounding thoughts.
Hash function.
Yeah, hash function. So yeah, basically, adding a key to an object is constant time, and yeah, because it knows the place in memory where to put that thing, and how it knows where to put that what that key or that value in memory is through the hash function. So from, I guess from the object perspective, you know, so we need to remember that big annotation is all about how long does it take to do something with respect to the input size, right? Here, it doesn't matter if we have one object with only one key. It's going to take the same time to add one more key that if we have an object with 1,000 keys and we add one more. It's going to take the exact same time. Even if it's 1,000,000 keys, it will still be constant time to add one more key. So, so with respect to the input size, with respect to the object, is constant time. That's correct. Now, if we go back, let's take a quick look at the lesson that we had on hash function, on hash table. This is how it is able to tell you the place in memory. Basically, a hash function will map a value. I think this graph can be a little bit confused because it's using object here, but these objects are the keys. It's going to map a key to a hash code, and in the implementation that we saw, what it does is it maps the key to an index in an array. All hash maps fundamentally are the same. That the hash function will take in some value. Let's focus on just taking strings as keys, and it does some math on it or computation. Most, the good ones, cryptographic computations to come up with a random enough index that can be repeated given the same key, produces the same value out, the same index where that's going to be stored. So this is like a simple example, like one key maps to hash code 4, another key maps to hash code 16, another key maps to hash code 125. And these hash codes, in the implementation that we have here, we use as indices, basically. So under the hood, a hash table it uses an array. It uses an array to be able to go to a specific place in memory. And this is an example in graphic example, basically. Or if we want to add the key F, let's see if I can annotate here. Let's say we want to add, so H is our hash function, so we can do just H for hashing. We're passing F, and this is going to give us an index. And this is our array. And an array in memory, and so on. So we hash our key, which in this case is F, just a single letter, and that's going to give us an index somewhere in the array that we're going to put it. And then that's basically why then adding a key to an object is constant time with respect to the object, because it's just doing doing some math on the key itself to figure out a place, a location, a pointer, an index to put it on in the underlying hash table array. And we know that going to an index in an array is constant time, also thanks to math, basically. Let me clear this out here. Oops. Here. Cool. Constant time. Now the hashing operation is all then, or it depends on the hashing, but the one that we have in the lesson is all then with respect to the key size, right? So if you have a longer key, then it's going to take longer to create that hash. But that's just the implementation that we have in the lesson. There are more advanced implementations have more intricacies. But yeah, inserting all of one constant time to add a key. How do we read or get do lookup or get something? How long does that take?
This would be constant time also.
Constant time also. Basically, because of the same reason, we hash the key that we want to look for. That gives us a pointer or an index to the underlying array that has the value that we're looking for. Constant time. What about finding and searching, where you don't know the key? And we saw that here. We did these functions like has value that takes in an object and a value to find. How long would it take, Jonathan?
Wouldn't that be O of n?
O of n. That's correct. Where n is what?
N is the value that you're trying to find among the keys.
Nope.
It would be the length of the object.
Right. The length of the object, or since I'll say where n is the length is the number of keys. Because objects don't really have length. Arrays have length. The number of key value pairs. And we saw that where we did this function here has values, and we see that it loops. It's doing a for in loop for every key in the object. So if we have 1,000 keys, they'll yeah. If you have what am I trying to say here? The finding a key, finding a value, or a key, I guess, if we don't know which one exactly we're looking for. Finding a value will increase in a linear fashion with respect to how many keys do you have, how many key value pairs you have in that. Cool. How long does it take in terms of big O notation to update or edit anything in the hash table?
Constant, as long as you know the key.
Constant, as long as you know the key. I think I really like that last addition. Because what happens if we don't know the key?
You have to loop over it, so it's of one. Of n.
Right. We'll need to search first before we can update it. Cool. Deleting something.
Same thing.
Same thing. So, as you see, this is what makes a hash table a very efficient data structure. For most of the operations of n, of one, where they operate the good operation like inserting, updating, and getting in a constant time. That's very good. Finding or searching sucks a little bit, but we gain in being able to get really fast, being able to add really fast as well. Okay. Cool. So any other additional questions about, I guess, the time complexity of these operations? There is one thing, one sort of extra detail here, which is, let's say inserting we say is constant time, and for 99.9% of the cases, that is correct. Constant time adding. When you're using a very poor or badly implemented hashing function, you're going to get collisions on the keys. And a collision on keys when, let's say you hash in hello and you hash in bye, and those two keys, hello and bye, happen to give you, as a result of the hashing function, the same index. So they collide on the same value. If we have a function that has that is not a very good hashing function, where we get a lot of collisions where multiple values map to the same index or to the same place in memory, then the insert speed can be affected. And this is what we have in here, where I hope you remember somewhat of this, where we had an array, and if we have a key that collides like here in H, so basically let's do here. You know, if we say this is our array and this is 0, this is 1, 2, 3, 4, 5, 6. This is our array. I think this is just a chunk. And we did hashing D. Hashing D gives us the index 4. And we did hashing F. And we also got 4. Just because we're using a very bad hashing function. We don't need to know about like the H hashing function. In this case, two things, D and F, map to index 4. And generally that's a bad thing, but we can work around it. The way in which we work around it is by adding a linked list. This is a linked list. You see that this D has the next pointing to the F. The F is pointing to null. The next is pointing to null, basically. So when two things map to the same, two keys maps to the same index or to the same bucket, we will need to implement a linked list to be able to have two things mapping to the same bucket. And if that's the case, then our linked list could be then be long. Let's say F, E, and keep going, J, and so on. So if your hash table starts to have a really long linked list, ideally your hash table is like this, that only has one node at the beginning of the linked list. But if your hash table has a long linked list in one of its buckets, then that means that you're using a very good hashing function. Which for the purpose of this course, it's okay. You know, it's more of the idea than us trying to implement a very good hashing function. So in this case, let's say we're looking for J. So we hash J, and we get 4. What we do is we compare J to the first thing in the linked list, which is D. Is this D? Is this J? No. If it's not, then we move on to the next thing. Is this J? No. Then we move on to the next thing. This is E. Is this J? No. We move on to the next thing. Is this J? Yes, we got it. So we can see that here. Then looping over this linked list can take time. So it is constant time to get to the bucket 4. Constant time to get here. But if you have collisions and you end up having a linked list that is long here, then that's going to add to your time complexity. In that case, we will say this is of 1. Wait, let me take a look at of 1 to get to the index, plus is of n. Where it's important to always say what is n. N here is n, where n is equal to the number of collisions. Where n is the number of collisions here. Or I could say x or any other letter here. So that is just a detail there on that. Yes, 99.9% is of 1, but if there is a bad hashing function, it's going to be of n or of x, where x is the number of collisions that you have. This is something I wanted to bring out there. Any sort of top level questions regarding this?
Yeah, I was a little curious about collision itself. I've heard a definition for collision somewhere else, and I was wondering if it still applies. Where like if you have two values being like two different values being hashed into the same hash value, they will be considered collision.
That's correct. These are all collisions because we are mapping D to 4. Our hashing function just happened to map D to 4, F to 4, J to 4 as well.
All right.
So that's why it's called collisions, because I guess all of them are pointing to the same thing.
Okay. I guess I was thinking of like actual like huge inputs that could be maybe changed or something like that to have a different. But I guess I'm thinking of something else. But yeah, okay.
I'll say just, if this still feels shaky, revisiting this lesson can clear it out, because here we have a hashing function. Let me clear this out. Here we have a hashing function that is this. This is a very simple hashing function, which is great to demonstrate the concept, but it's not a great hashing function because it's going to map. For instance, we have it here. This hashing function, if we pass in bean, it maps to 375, 376. If we pass in dane, it maps to the same value, even though the keys are different. It maps to the same value just because if we look here at the code, the only thing that this is doing is iterating over the key and adding up the character codes of each character, basically. And it just happens these two have the same letters. That sum will be equal to the same sum. So this has an example of a collision there. Cool. So let's jump into some of the collision part, and it is important to like this. This is important to have present, and you can do this for all data structures. You can, in fact, I'll encourage you to. This is something that I did. I'm not gonna share it just because I think you should do your own. I put all the data structures. Hash arrays, linked lists, stacks, sets, binary tree, etc. And I put the cons, what they created at, what is the cost of creating, inserting, reading, looking up, finding, searching, deleting. I'll encourage you to create some of this grid for you as well, where you map out the time complexity for these operations. Cool. So let me close this. Okay, so what I want us to do is, in the 38 minutes we have left, is take a look at this question. So if you have already solved these questions, I'll still encourage you to solve it again. This in particular unique number of occurrences. Actually, no, this one took me like, I have solved this question 3 times in lead code. Last time, that was today actually, it took me about half an hour. I was struggling to remember something. Hopefully you don't take it as long as I do. So what I want to do now is pair you up, and where you can go in and do those, try to do at least these 2 questions in your pair. So let me see.
Sorry, do you have the link for this one? Sorry.
Oh yeah, I had shared it earlier, but I think, let me share it here again. That is, if I can find where the chat is. It's here, chat, there we go. And I'll say let's take 20 minutes to do that and be back here like 15 minutes before ending the class for us to just do sort of a quick review of that and just go home, even though we are already home. Cool. So I think I had paired you up already with the people that I was working in earlier. But I think I'm gonna switch it around because you probably, wait, does anyone have the breakout room button at the bottom of Zoom?
I still have it.
You still have it? Okay. Okay, so I think most of you should have it. Just go in and join. What happens when you click that button, Cameron?
It tells me I'm going to breakout room 3. I have an option.
Yeah. Okay. Yeah. Then everyone just look into the breakout. Go to the breakout room that appears in the breakout part. And let's be back here at 9:45.
Cool.
Hi, Chuck.
Hi. Sorry.
Yeah.
Alejo, I'm in
Yeah.
I'm in break room 6, but then I'm the only one there.
Oh, that's correct. Where is? Oh, I guess Chuck went away. Okay, I'm gonna send you to a group of 3 with 3 people.
Sure.
Cool. Did you get the window? No.
So I'm assigned to break room 5.
That's correct. Yeah. Try to go to that one.
Okay.
Cam's is a little cleaner than mine.
Sure. Let's take a look.
Like I have a messy window with all this Zoom stuff.
I
Yeah,
see.
so basically we just have a double loop going on here. It's a very simple version. Might be considered brute force, I guess. But yeah, the first loop just looks at the each number in the array and then compares it to every other number in the array.
So yeah, I was just talking to another team that they were suggesting this approach, and this works. However, what is the time complexity of this?
Of n square.
Of n square, correct? Quadratic time. This works, but for this problem, we could do better if we use an object, which was we were intending to. Anyone managed to get the object there?
Yeah, me and Janesh, we did. We made 2 objects actually.
Cool. One of you can share the screen.
Janesh, you want to do it or you want me to do it?
Oh, you can do it. I actually closed it already.
Oh, okay. Let me go to
You have it open?
Yeah, I have it open. Let me go to it. Share. I don't know. Can you guys see this?
Yeah.
Okay. So we had 2 objects. We had a count object and an occurrences object. So at first, we went through, we looped over the original array, and if that value existed in our object, we updated our count. We added 1 to our count. But if we hadn't seen it, we set it to have a count of 1.
I'm going to draw that object here so we see as it's going on. So we start with an empty object.
Actually, the other question.
Say that again?
I think Olay was doing the 2 sum one, not this one.
Are you?
Oh, yes, the 2 sum.
Well, never mind.
This was the
unique occurrences. That's the one we did.
Okay, anyone did the 2 sum with the object? Okay.
I did. I didn't do it today, but I've done that problem before.
Okay. You don't have the code at hand that we can look at it right now.
I actually might have it. Let me pull it up.
Oh, I think I also had.
Oh, cool. I do. I have the code, but yeah.
Do you want to share your screen?
Sure. Oh, wait, I thought that was it. No, I don't have the code.
Okay. That's fine.
Yeah.
Oh, I did it. I have it. I did it 3 months ago. I have it.
Cool.
I have the right one.
The first time I did it, it said it was 2 years ago.
Let me see if it will. First, let me make sure that it's going to pop up. Let me share.
Oh, never mind.
Share. Oh no, where's my solution? Where did it go?
Yeah, go to this. Yeah, there. Click on accepted.
Okay, it's at the bottom, I guess. It was just here. Okay.
Cool. So let's talk about this before we close off.
Okay. So I made a 2 sum function that takes the numbers array and also the target value. And then I initialized an empty object.
Okay.
And I'm making a loop over the numbers array.
So let's run with this. Let's run with this example where we have 3, 2, 4, and the target number we're looking for is 6.
Okay. So as I'm looping through, I have a variable called opposite, where it is the target minus the value at whatever index I'm at. So in this case, it would be 6 minus 3, would be opposite.
So 6 minus 3 would
which
be
gives me a 3.
3. Okay, so we get that 3.
And now if the value of 3 is greater than or equal to 0, I'm going to return the index of, what is it? The index of the opposite in the array and its index. So 3 and 3, that would give me an index of 0.
Well, actually, this part here you could have done it will be just nums. Wait, not nums. Object at opposite. I think. Are you, because you're doing this here? So you're saving the index as the value. So you're gonna end up with an object that looks like this: 3, 2, and 4, and the value
the index
will be the index. So that's 1, 2. So here, this part here is doing an unnecessary loop. It works, but this is an unnecessary loop where you're searching again for the opposite on the array. I think there you could just do nums I. Not nums I. Object at opposite, basically.
Okay.
At opposite. I'm just gonna abbreviate it like that. Because object at opposite already is gonna give you the
value.
The index, which is the value of the object. That's correct. So this is, you're checking if it's greater than 0, greater or equal to 0. I see why you were doing greater or equal to 0. It's a little bit confusing, but basically what you're doing here is checking if there is a key in this object. So here it's important to note that here we're mapping the num to the index. And this is what is part of interesting about, like, in an array, we have indices mapping onto elements. This object is doing the opposite of that, which is mapping the number itself, the element, to its index, so that we can access the index really quickly. Here, though, what you're doing here is just checking if the opposite is at all in the object, right? In this case, the first time that runs, the opposite is 3. 3 is not in the object, right? So this is the first time. 3 is not in the object. 3 gets added. With 3, we fall in here. 3 gets added to the. I'm gonna erase this. Right, so 3 got added to the object with its index. This is what that line here under here is doing. And then let's keep going and see what we get. So then this one made it.
So then 2, right?
So we move on to 2.
So let opposite here. Target minus 2. So 6 minus 2 is 4.
Okay.
This was 4 currently there. Wasn't, but it adds it. So now we would have 4 with a value of 2.
Right. No, it added 2. Well, it did add. It added 2 with the key set to 1, which is I.
I skipped that, jumped ahead. Yeah.
Yep. And then from there, it moves on to 4, which is this guy.
Right. So 6 minus 4 gives us 2. Is 2 greater than, no, is the object at 4 greater than or equal to 0?
But not the object at 4, the object at the opposite, which is 2.
2. Is that greater than or equal to 0? Which, yes, because it's in there already. So we'll return 2 and I. So what is that, 1?
That's correct. It will be to the index was 2, and the value of that you have here, which is 1.
1. Mm-hmm.
And we got that there. Great. Thank you for sharing this, Rihanna.
Mm-hmm.
I'm going to share another solution in the class chat as well. It's this thing